Kia ora, and a warm welcome to this exciting journey into the world of SQL. This is your ultimate guide to mastering SQL, structured query language, the backbone of modern data management and analysis. SQL is the universal key to unlocking the power of data in today's digital world, enabling organizations and individuals to make sense of vast amounts of information. Whether you're a student, a professional, or simply curious about technology, this guide will take you from beginner to confidently interacting with databases and understanding how data shapes our world. We'll explore what SQL is, its crucial role in relational databases, and the two main command categories that form the foundation of database operations: Data Definition Language, or DDL, which is used for structuring and organizing your databases, and Data Manipulation Language, or DML, which allows you to work directly with the data itself, retrieving, updating, and deleting information as needed. By the end of this guide, you'll know how to create databases from scratch, populate them with data, and extract meaningful insights that can drive decisions and innovation. SQL is designed specifically for managing and manipulating data in relational database management systems, which are at the heart of countless applications and services we use every day. Its syntax is straightforward and resembles plain English, making it accessible to beginners and powerful enough for experts. That's why SQL is one of the most widely used programming languages in the world. DDL commands like create table help you define your database's structure, setting the stage for efficient data storage and retrieval. Meanwhile, DML commands such as insert, update, and delete empower you to add, modify, or remove data as your needs evolve. Together, these tools make SQL an essential skill for anyone working with data, opening doors to new opportunities in technology, business, and beyond. Before writing SQL queries, you need a database environment. A database is an organized collection of data managed by a database management system, DBMS, like MySQL or PostgreSQL. Setting up a DBMS is simple. Download, install, and you're ready to go, often for free. To create your first database, use a command like create database, my first database. This sets up a blank space for your data, ready for tables and information. Security is crucial. Set up user accounts with only the permissions they need. Connect to your database using a command line tool or a GUI like dbeaver. Enter your server address, username, and password to access your database. Once connected, you have a blank canvas for your data. Next, you'll define your data structure by creating tables. Now, let's give your database structure with tables. Tables organize data in rows and columns, like a spreadsheet. Each column is an attribute, like name or age. Each row is a record. Use create table to define tables and specify columns. Assign each column a name and a data type. INT for numbers, varchar for text, date for dates. For example, to store students, create table students, student ID int, name varchar 100, email varchar 100, enrollment date. This command creates an empty table with defined columns. Data types ensure only valid data is stored in each column. You can't store text in an INT column, for example. Designing tables carefully is the foundation of a reliable database. To uniquely identify each row, we use primary keys. A primary key is a column with unique, non-null values, like student ID in the students table. Define it as primary key to enforce uniqueness. Create table students, student ID int primary key. This prevents duplicate IDs and ensures data integrity. To link tables, use foreign keys. For example, an enrollments table might have student ID as a foreign key referencing students. This enforces referential integrity. No enrollment can exist for a non-existent student. If you try to insert or delete data that breaks this link, the database will block it. Primary and foreign keys are the backbone of relational databases. They allow you to build complex, interconnected data models. SQL lets you enforce rules on your data with column constraints. Not null ensures a column always has a value, useful for required fields like name. Unique enforces that all values in a column are different, perfect for email addresses. Default assigns a value if none is provided, like status varchar 20, default active. Check enforces custom rules, such as age int check age unnamed 16. These constraints keep your data accurate and reliable. For example, a student's table might require unique emails and non-null names. Constraints prevent invalid or inconsistent data from entering your database. They're essential for maintaining data quality. Use them to build robust, trustworthy databases. With your tables and constraints set up, you're ready to dive into the heart of database work: adding, viewing, and changing data. This is where SQL truly shines, giving you the power to shape your information exactly as you need. To add new information, use the insert command. For example, you might write insert into students. Student ID, name, email, enrollment, date. Values: 1. Tain Mahuta, tain.meexample.co.nz, 2026, while 10. This creates a brand new row in your table, capturing all the details you specify. To see what's in your database, use Select. You can view everything with Select, from students, or focus on just one column, like Select Name from students. Select lets you explore your data in countless ways, from simple lists to complex filtered results. In fact, Select is the most used SQL command, essential for querying and analyzing your data. Whether you're checking a single record or generating reports, Select is your go-to tool. When you need to change existing data, use Update. For instance, update students. Set email, jange new.email example.co.nz, where student ID janim1. This updates only the record you specify, keeping your data accurate and up to date. Always include a where clause with update to avoid accidentally changing every row in your table. The where condition acts as a filter, targeting only the records you intend to modify. To remove data, use delete. For example, delete from students where student ID NUR1. This command erases only the row that matches your condition, helping you keep your database clean and relevant. Again, where is crucial with delete. Without it, you risk deleting all your data by mistake. Always double-check your conditions before running these commands. Insert, select, update, and delete form the core of SQL's data manipulation language, or DML. These commands are the building blocks for working with data in any relational database. With these tools, you can add new records, view and analyze information, make changes, and remove outdated data as your needs evolve. Mastering these commands is essential for anyone who wants to work confidently with databases, whether you're building applications, analyzing data, or managing information systems. The where clause lets you filter data to find exactly what you need. Use where and select, update, or delete to specify conditions. For example, select from students, where student ID, CHAQ1, returns just one student. Combine conditions with and or for more complex queries. Use comparison operators like da, ba, 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 ba for numbers and dates. Between selects values in a range, where age between 18 and 25. Like searches for patterns in text, where name like T-cent. In matches multiple values, where country in New Zealand, Australia. Is null finds missing data, where email is null. Where is essential for precise data retrieval and updates. It's the key to asking the right questions in SQL. Make your results more useful by sorting, grouping, and summarizing data. Order by sorts results. Select name from students. Order by name ASC, DESC sorts in reverse. Order by enrollment, date, DESC. Distinct returns unique values. Select distinct city from customers. Group by groups rows for summary. Select enrollment, year, count student ID. From students. Group by enrollment year. Aggregate functions like count, AVG, max, MN, and sum provide insights. For example, count student ID shows how many students enrolled each year. These tools help you analyze trends and patterns in your data. Sorting, grouping, and aggregating are vital for data analysis. They turn raw data into actionable information. SQL's true power comes from combining data across tables and leveraging advanced features that go far beyond basic queries. As your data grows, understanding these concepts becomes essential for efficient and effective database management. Join operations allow you to merge rows from multiple tables based on related columns, making it possible to analyze complex relationships within your data. Inner. Join, for example, returns only the records with matching values in both tables. For instance, select students.name enrollments.course name from students. Inner join enrollments on students.student.id tax enrollments.student.id. This is crucial for extracting meaningful insights from related datasets. Indexes are another advanced feature that can dramatically speed up searches, especially on large tables. By creating indexes on columns you query often, you can reduce query times and improve performance. Use the create index command for faster lookups, but remember that while indexes boost read performance, they can slow down data changes like insert, update, or delete operations. Always balance indexing with your workload. Transactions let you group multiple changes into a single unit of work. Commit saves all changes permanently, while rollback undoes them if something goes wrong, ensuring your data stays consistent and reliable. Alter table is a powerful command that lets you add, remove, or change columns and constraints as your needs evolve, making your database structure adaptable to new requirements. SQL's flexibility means your database can grow and change alongside your business or project, supporting new features and data types as they arise. Mastering these advanced features like joins, indexes, transactions, and schema changes sets you apart as a true database professional, capable of handling complex data challenges. With SQL, you're empowered to store, retrieve, and manage vast amounts of data efficiently, making it an indispensable tool for modern data-driven environments. Whether you're building applications, analyzing business trends, or supporting decision-making, SQL is an essential skill for anyone working with information today.